Hi, welcome back again to the channel. For this video we are going to prove the famous Pythagorean theorem. So it is also taken from the book Geometry in Figures. Of course, there are so many proofs of Pythagorean theorem and you can pick and choose which one you like. Even someone is writing a book which consists of more than 100 proofs of Pythagorean theorem. But forget about that. Let's just try to prove using some similar triangle properties. Okay, so here we have in the situation that we have a right triangle and we would like to show that AB squared plus BC squared is equal to the hypotenuse squared. Okay, so how we can proceed? So first let's us draw some segment here. Draw an altitude from B to AC. So this must be perpendicular, right? And then let this angle be alpha, and the other one, let's call it beta. Since this is a right angle, then certainly alpha plus beta is equal to 90 degrees, or alpha and beta are complementary to each other, right? So alpha plus beta is equal to 90 degrees. Okay, but this guy is also a right angle, and that's alpha. So the other one must be the complement of alpha, which is beta. So here is beta as well. And again, this one is a right triangle where one of its angle is beta. Therefore, the other one must be the complement of beta, which is alpha. Okay, so notice then we have three pairs. We have three triangles which are all similar. Which one are those? The first one is the biggest one here, right? So we have A, B, C. So pay attention on the order of how we wrote the vertices. So we write A and B and C. So A, which has the angle alpha, beta, which has the angle right angle, and C, which has the angle beta. Okay, so this guy is similar to, for example, what? A, let's call this as D. ADB. Why is that? Because similar to the previous one, the angles, the corresponding angles are alpha 90 degrees, beta. Similar to what we listed before, alpha 90 degrees and beta. And also we have the smaller one, this one. So again, we need to make sure we write all the vertices in the right order. So the angle alpha first, and then the 90-degree angle, and then the beta angle. So then the order of the vertices will be BDC. Okay, now we somehow want to make this expression appear from the ratio between the side of the triangles, right? So in particular, let's say we want to make AB squared somehow appear. Okay, so here pay attention on the side AB here, right? Okay, and then we need another AB that appear in the other triangle, in another triangle. So how can we get the side AB? By using the first and the third vertex, right? So then if we consider the ratio between AB and AC, then on the second triangle, this ratio must be equal to the ratio of AD to AB. Okay, so we purposely consider these proportions. Why? In order to get AB squared, which we can get it if we cross multiply this equation. So this will imply that AB squared is equal to AC times AD. Okay, so now try to do the same thing for BC squared. If you would like to try, you can pause the video for a while and then you can come back again. Okay, so similar to our previous reasoning, we would like to make BC somehow appear. So that's BC. Where else we can have BC? On this triangle, which is from the first and the third vertices, right? So then we need to compare this 2 with this one. So BC over AC will be the same to DC over BC. So BC over AC is equal to DC over BC. And similar to what we had before, if we cross multiply, we have BC squared equal to AC times DC. Now if we add the left hand side, we exactly get that guy. But what happens if we add the two right hand side? So the sum of these two will be equal to what? AC times AD plus DC. But what is exactly this guy? What exactly this guy is? AD plus DC is exactly AC. So this is nothing but AC times AC, which is AC squared. And we are done. So the Pythagorean theorem is true since 2 millennia, and nothing so important here, but it is fun that we can prove this theorem in so many ways. Okay, so that's all for now. See you again on the next video. Bye bye.